Compound interest. Welcome, everyone. So for compound interest, we're still dealing with principal, we're still dealing with interest, and we still have the idea of a future value or an accumulated amount. However, the way that the interest applied is a bit different. So let's review our definitions. The principal in financial formulas is the balance on which interest is paid. This is the starting amount of money that is invested or paid. The interest earned on an account is money paid for the use of money lent, or sometimes when you're saving money. Okay, the accumulated amount is the total amount of money paid or returned when an account is closed. It is the principal along with any interest that is paid. And we very frequently refer to this as future value, FV. Compound interest is interest paid on both the principal and the interest added to the original investment. So if you have ever had a credit card that got away from you a little bit, most people perhaps, you would see that maybe you bought a TV for $1,000 and now you owe interest on that. Okay, well, now you can't pay it off. And guess what? So now you owe interest on the TV plus the interest from last month. So you're earning interest on the interest, and it kind of can snowball. But on the other hand, if you were to invest money or save money, this could work in your favor. But the idea is that the interest is put back onto the principal or back into the account, and then it itself earns interest. So it's interest on interest. All right, our compound interest formula, A equals P times 1 plus R over N to the NT. A lot of letters here. So A is our accumulated amount or our future value after a certain amount of time T in years. P is our principal. It's our initial deposit, our initial cost of our TV. It was what we put in our savings account when we were 5 years old. Thanks, Mom. Okay, R is our interest rate written as a decimal. N is the number of times it's compounded in 1 year. And we're going to talk about that in the next slide. T is time in years. So we have to talk about compounding periods. So typically, like if you think of a credit card, if you think of a savings account, if you think of a loan, what's happening is interest is being applied to those accounts at the end of every month. So that's why you get a monthly statement. It says, hey, this is how much interest you accrued, or hey, this is how much interest you earned in your savings. So when you do it monthly, right, that is 12 times per year. So compounding periods tells you the number of times interest is compounded each year. It's usually given to you in an English word. So for example, yearly, that's once per year. So little n is 1. Semi-annually, that's twice a year, n is 2. Quarterly, that's 4 times a year, n is 4. Monthly, that's 12 times a year, so n is 12. Weekly, there are 52 weeks in a year, so n would be 52. And if you did it daily, we're going to call that 365. So future value with compound interest, this is the most straightforward way to do a compound interest example. How much money do you have in a bank account after 6 years if you invest $1,500 at 3.5% interest compounded semi-annually? And we're going to pretend there's a question mark at the end of that. It has appeared. All right, so if we run through the problem, we can pick out our values. In particular, the first one that comes up is 6 years. So that's going to be our T. And we're investing 1,500. So that's the initial amount we put in. That's going to be P, our principal. 3.5% is our rate. Semi-annually, it says compounded semi-annually. And we just mentioned that that was N equals 2, or twice a year. And we're using our compound interest formula. So A equals P times 1 plus R over N to the NT. So let's capture our data. We don't know our account balance, our accumulated, or our future value. Those all mean the same thing. I don't know how much money I'm going to end up with, but I do know I'm going to invest 1,500. That's P. I do know that my rate is going to be 0.035 as a decimal. I know that N is 2 because it said semi-annually, and I know that T is 6 years. So I can plug these in And I'm going to get A equals 1,500 times the quantity 1 plus 0.035 over 2 to the power of 2 by 6. So we need to really rely here on PEMDAS because if we do it out of order, we're going to get the wrong answer. So let's go ahead and work within the parentheses first. 1 plus a fraction. I'm going to take that fraction. I'm going to take 0.035 and divide it by 2 and give myself a decimal. So I still have my 1,500 and then 1 plus 0.0175. And I didn't do anything to the exponents. So now I'm going to continue working within my parentheses, just adding 1 to the decimal. So I get 1,500 times 1.0175 to the 2 by 6. Now that my parentheses are done, I can move into E, exponents, and I can take 2 by 6, and I'm going to get the exponent is 12. So now that I have that, I can apply my exponent to the base, 1.0175. And that's going to give me 1,500 times 1.231439315. And for this unit in particular with finance, it's so crucial that we keep a long string of decimals until the very, very end. We're not going to round until we absolutely have to at the very end. We're usually, if we're being asked for money, we're going to round to 2 decimal places. So let's find some space, some real estate. I'm going to multiply those two numbers together. I get 1847.158972. And this is the account balance after 6 years. So I want to round this to 2 decimal places because it's money. So I get 1847 and 16 cents. And that is compound interest.